Good day, everyone. Welcome back to my YouTube channel. In today's video, I'll be teaching you how to construct balanced ionic equation from half equations. But before we proceed, what is an ionic equation? An ionic equation is a chemical equation that shows only the ions and molecules that are involved in the reaction. For example, we have one here on the screen. Aqueous chlorine reacting with bromide ion to give us aqueous bromine and aqueous chloride ion. Now, these two here are ions, and that is why this is an ionic equation. Furthermore, what is a half equation? A half equation is a chemical equation that shows either the oxidation or the reduction part of a redox reaction. Now, what is a redox reaction? A redox reaction is a reaction in which reduction and oxidation are occurring simultaneously. Now, there are so many definitions for reduction and oxidation, but the most common one that we're going to employ in this class is the one that has the acronym of oil rig, in which the O represents oxidation. That means oxidation is loss of electron, while reduction is gain of electron. Quickly, we'll be looking at a few examples to explain how we can construct a balanced ionic equation from half equation. The first example says zinc metal react with iodized ions in acidic solution. Construct a balanced ionic equation for this reaction using the two half equations shown below. So this is the formula of the iodized ion that we have here. And the question says that it is in an acidic solution. So most of the time in chemistry, when we're talking about acidic solution, we represent it with a proton, that is hydrogen ion, as you can see there. And then these are the products that we have here. Now balance and to balance half equations in order to get the full equations, what we are usually after is the electrons. That we use the number of electrons to balance the whole equation. So in what we have here, for the so this the first equation here is the reduction equation. That is because electrons are gained. So from what we can see here, 10 electrons were gained, and that the second equation is showing the oxidation parts of the whole equation. And that's because 2 electrons are lost here. So for us to construct the full equation, we need to balance the number of electrons. In the reduction part, we have 10 electrons, and then in the oxidation part, we have 2 electrons. So what do we need to do? We'll multiply the oxidation part by 5 in order to do what? In order to balance the equation. So putting that 5 there, so we use that to multiply everything. So that is 5 moles of zinc to give us 5 moles of zinc 2 ion, plus 10 electrons. Now, since the electrons here are balanced, we can cancel out the electrons, and then we write the remaining parts of the equation. We combine it together, and that will give us what we have here. So we have the 2 moles of the iodized ion plus 12 moles of the hydrogen ion plus 5 moles of the zinc. Now everything will now be giving us the iodide that we have there plus 6 moles of water plus the 5 moles of the zinc ion. And this is our full ionic equation for this example. The second example that we'll be considering for today's lesson is this: construct a balanced ionic equation using the half equations shown below. So we have this, the first equation here is at oxidation, reaction. And that is because electrons are lost. So this is an oxidation reaction. And that's because 6 moles of electrons are lost here, while the second one is a reduction. And that is because electrons are gained. 2 moles of electrons are gained here. Like I said earlier, to balance this equation, the number of electrons has to be what? Has to be equal. So what do we need to do? We need to multiply the second equation here with what? The difference between the number of electrons is 3 in the ratio of 3. So we multiply the second equation here by 3. And that will give us 3 chloride ion plus 3 moles of water plus 6 moles of electron. That will give us altogether 3 moles of chloride ion plus 6 moles of hydroxide ion. Now we need to add up the first equation here with our new equation that we just got here. So our final answer will be this. So we have the bromide ion up there plus. Now, before we go on, we need to check something here. We can see here that we have 6 moles of hydroxide ion in the first equation. And then in the second equation, in the equation that we just derived here, we also have 6 moles of hydroxide ion. So what do we need to do? We cancel those ones out because they are equal. Also, looking at the equation on top here, we have 3 moles of water molecule. And then in our derived equation here, we also have 3 moles of water molecule. So we also cancel that out. And then we add up the rest. We add up the remaining parts of the equation. So here we have the bromide ion plus the 3 moles of the chlorate ion. And that will give us the bromate ion plus 3 moles of the chloride ion. So this is our full ionic equation. The last example that we'll be considering in today's lesson is this. Construct a balanced ionic equation for this reaction using the two half equations below. As usual, we need to take note of which of them is a reduction and which of them is an oxidation. So from what we can see here, the first equation here is losing electron. Lithium here is losing 1 electron to form lithium ion. So this is what? This is an oxidation reaction. While in the second equation here, iodine is gaining 2 electrons to give us 2 moles of iodide ion, and that makes it a reduction. So in order to balance this equation, we need to check the number of electrons. In the oxidation part, we have 1 electron, and then in the reduction part, we have 2 electrons. So we need to balance that. How do we do that? We multiply the first equation by 2. And that will give us this 2 moles of lithium to give us 2 moles of lithium ion plus 2 moles of electron. And then we can move on to balance this equation since the number of electrons are the same. All we have to do is to cancel out the electrons first. And then we write the remaining parts of the equation there. So here we have 2 moles of the lithium ion plus the iodine, which is in solid state, to give us 2 moles of the lithium ion plus 2 moles of the iodide ion. And this gives us the balanced ionic equation. So in today's video, I'm going to be leaving you with this question here for you to try out on your own. I'll be waiting in the comment section for your answer. I hope you enjoyed today's video. and you've seen that balancing of equations to derive and a complete ionic equation is not something difficult. Please remember to subscribe, to share, and like this video. Thank you for watching. See you in the next video. Bye for now.